Ho 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 ho! It's freaking Christmas, folks. Normal people use December as a time to not work and watch Netflix all day. But we're not normal people, we're software engineers. So December equals Advent of Code. Now, in the last couple of years, I've used Rust, I've used Haskell, I used a couple more. This year, we are using Go. Let's write some code. Okay, day one, part one. So the idea here is that we get an input file where each line is alphanumeric characters, and from each line we need to do the following. We take the first and the last digit, we compose a number by putting those two digits together, and then we sum all of the numbers we create for each line to get the final result. So in this case, for example, the first line would give us first digit 6, last digit 1, so 61. Second line would give us 11. Third line would give us 43. We would sum those numbers together and we would get the final result. Let's see that in code. So, okay, the solution is pretty simple. We read the file and we pass it as a string to the function part1. Then part1 takes the file and reads it line by line using a scanner. And it first tries to parse a digit going from left to right for each line. As soon as it parses successfully one digit, we save it as first, and then we break the loop. We do the exact same thing going from right to left. And then we compose our number with some simple arithmetic, and we add it to the total sum, which we then return at the end of reading the entire file. The parse function is simple too. So we take the byte, because strings in Go are slices of byte. So when we extract one character, we actually get 1 byte. We check if that byte is a digit between 0 and 9. If it is, we transform that digit into an integer with some simple ASCII arithmetic. And we mark the parsing operation as successful with this true. Otherwise, we say we couldn't parse any digit. Now, this works. And as a benchmark, this solution takes 95 microseconds. Interestingly enough, we can actually change something here. So instead of using a reader, we can extract the line with some brute forcing, I guess. We use the split function, and we take our input file and we split on new lines. And here, of course, we need to range. And the solution takes 84 microseconds. Not that it matters so much, but this was an interesting find. Day one, part two. So here there's a twist. Besides parsing digits, we also need to parse the strings into digits. So for example, the first line, the first digit this time will be 2 because we have the substring 2 at the beginning here. So for this line, we would be using 21. For the second line, the first digit here is actually 8 and not 1. And the last one, I guess, would be 4 because there's the 4 here. Okay, so the solution here is pretty similar to the part 1. So we get the input, and for each line, we use a different parser, which we called parse digit 2. And this time, instead of just passing one character or 1 byte, we're passing the line starting at the index I, because we keep trying to parse the first digit either as a digit or as a word. Now, the way it works is that we get the substring str, and we first try to parse the first character in that string using the parser we had for part 1. If that doesn't work, we try to see if the string has a prefix that is either 1, 2, 3, 4, 5, so on and so forth. And if we found a match, we return index plus 1, because at index 0 we have the string 1, so we need to convert it, right? So this all works, as we can see from the test. but it takes 553 microseconds. We could do something else instead, which is the following. So we add some optimizations to our parser. So first of all, if the substring is of length 0, we will not be able to find anything, so we already returned false. Then we try our parser for the first part of the day 1 of Advent of Code. If that doesn't succeed, we check if the length of the string is less than 3, because if that's the case, we would be not able to parse anything, because the shortest string digit we have, for example, is 1, which is composed of 3 characters. And then we have a decision tree where we check what's the first character. For example, in this case, if we found that is E, then we check if the length of the substring is 5 or more, because in that case, it's possible we would find as the subsequent characters I, G, H, T, which would be 8, and then we would return 8. This goes on for the rest of the characters. And if we try this solution instead, we would see that the benchmark is way faster. And that is day 1 of the Advent of Code. Let me know what we would have done differently. I'll see you in the next one.